All right, guys, are there any questions over any of the assignments? Any question over any of the assignments we've had so far? Guys, we're going to focus up here. If I'm going to have to get on to y'all for talking, I'm going to split that group up. Now, the first thing we're looking at is the zero product property. Now, if we have a quadratic equation, ax squared plus bx plus c, that is equal to 0, then we can use the zero product property. Now, when we talk about the zero product property, what we're really talking about is looking at something, say, a times b is equal to 0. A times b is equal to 0. Well, if we have two things multiplied together equals 0, what do we know one of the two things must be? 0. Because the only way we can multiply two things together and get 0 is if one of these two is 0. Or it could be both of them are 0. And the zero product property states if the product of two expressions, two terms or two things is 0, then one or both of them must be 0. That's all the zero product property is stating. If we have two or more things multiplied together and they equal 0, one of those things must be 0. So if we look at this first problem here, we have k plus 1 times k minus 5. We have two things that are being multiplied together that are equal to 0. So one of these two things, according to the zero product property, must be 0. So we're saying that either k plus 1 is equal to 0 or k minus 5 is equal to 0. We're saying one of these is. And now we solve. So for k plus 1 equals 0, well, the first thing we can do is subtract 1 from both sides, which tells us k is equal to -1.
Question.
Yes.
If k is equal to -1, doesn't that mean that k over there is equal to -1 as well?
Because -1 minus 5?
Yeah.
Is that 0? No.
So how can k and the other k equal different things?
Then either one or. Because we'll have two different values for k in most cases. They might not be unique values, but we will have two values for k in any quadratic. Any questions on this so far? Now we could check this here by plugging it back in and say -1 plus 1 times -1 minus 5. Well, -1 plus 1 is 0. 1 minus 5 is -6. And 0 times -6 is indeed 0. And we can do the same thing with 5. We can say 5 plus 1 times 5 minus 5. Well, 5 plus 1 is 6, but 5 minus 5 is 0, telling us that the whole thing is 0. And all I'm doing is checking it to see, does it indeed give us 0? We don't have to do this, but this does show us that the values for when k is -1 and 5 do give us a value of 0 if we plugged it back in. Any questions on any of this here? So let's look at this one here. So this one here, we have 2m plus 3 times 4m plus 3 equals 0. So we do have two things multiplied together to equal 0. So one of these two, either 2m plus 3 is going to equal 0, or 4m plus 3 is going to equal 0. One of these two things is going to equal 0. Now we need to do is solve for the value of m. So the first thing we can do here is subtract 3 from both sides, which is going to tell us that 2m is equal to -3. And then we can divide by 2, telling us m is negative 3 over 2, negative 3 halves. No, it'll simplify to negative 1.5 if we want to turn it into a decimal. But 3 and 2 do not have any common factors, so we can't reduce it any further than this. Now we can do the same thing to the other side. The first thing we can do is minus 3 from both sides, which will tell us that 4m is equal to negative 3. Then we can divide by 4. And those are our two answers. Almost. Any question on any of these here? All right, let's look at the next one. So here we have two things multiplied together to equal 0, yes? Well, we have x squared plus 10x plus 21. We have three things added together, yes? And when we were working with yesterday and Thursday, was rewriting a quadratic, like x squared plus 10x plus 21, as two sets of parentheses being multiplied together. So if we can factor this, then we can actually solve it. And the first thing we look at with factoring is a greatest common factor. Is there a number that will go into all three terms? No. So we'll start off with our two sets of parentheses with three spaces. And this is going to equal 0. And whenever we work with these with factoring, we want to get them to equal 0. So if there's numbers or terms on one side, we're either going to add or subtract them over to get it back to equal to 0. Yes. Throwing a baseball, skydiving, any type of objects being thrown and draw. Because you can use it based off force, gravity, and different variables. You can actually determine the place that it will land and the maximum height it can reach based off those factors using these here. And the location that it would hit is when it would be 0, because the height would be 0. Not too bad. Well, we know where it should hit. Doesn't mean it will hit. You can also use this with artillery. You can determine where a shell would land based off of the trajectory and the angle of elevation of the gun. All right, let's bring it back here. So the third term is positive. So the signs are the same and they match the sign of the middle term, which is positive. So we have plus and plus. Now we want the factors of the first and third term. Well, the factors of x squared are x and. Now the factors of 21, we have 1 and 21 or 3 and 7. Which one do we want to try first, 1 and 21 or 3 and 7? Now we can check this here. Now since we're solving it, this checking part's not the end. So we want to put it off to either side. We don't want to write the check right underneath, or we're still going to do the work and solve this out. So over to the side, we can say x times 7 is, and 3 times x is going to be plus 3x, which does give us 10x, which is what we wanted. So these are the correct factors. So we would have gotten 22x. Now that we factored it, we do have two things multiplied together that equal 0. So it's telling us that either x plus 3 is equal to 0 or x plus 7 is equal to 0. So here we can subtract 3 from both sides, telling us x is equal to negative 3. Here we can subtract 7 from both sides, telling us x is equal to negative 7. And both of these here are the correct answer. And if we plugged them back in, we could see it would show us that they do both work. Because we could say negative 3 squared plus 10 times negative 3 plus 21. And see if this is equal to 0. So here, we could say negative 3 squared plus 10 times negative 3 plus 21. 0. We can do the same thing with negative 7. Negative 7 squared plus 10 times negative 7 plus 21. We get 0. So both of these values of x will make the function equal 0. Any other questions on any of these here so far? Now, if it does ask to check, we can plug it in, say 0 is equal to 0. We don't have to write it all the way out, but we can at least set it up and then show that it does equal 0. And again, there will be points if it does say to solve the following quadratic and check your answers. I'm going to want you to at least write it out and say 0 is equal to 0. Easy points. Let's look at the next one here. 4x squared plus 20x minus 24. Is there a greatest common factor between these three terms? 4. So we can factor it out. 4 times, well, 4 factored out of 4x squared is just x squared. Plus 4 factored out of 20x is 5x. Minus 4 factored out of 24 is 6, and this is equal to 0. Now we can set it up as 2 sets of parentheses with 3 spaces. Now we're looking for the sign. If the third term is negative, the signs are opposite. If it's negative, the signs are opposite. If the third term is positive, the signs are the same and they match the sign of the middle term. Well, since it's negative, one of these is going to be positive and one is negative. Factors of x squared are x and factors of 6. 1 and 6, or which one do we want to try first? 2 and 3. And lastly, we can check it. X times negative 3 is negative 3x. 2 times x is plus 2x. Negative 3x plus 2x is negative x. Is that what we wanted? No, we wanted positive 5x, yes? Well, we could change the 2 and 3, but that won't do enough to get there. So we can do 1 and 6. Do 6 and 1. X times negative 1 is negative x. 6 times x is going to be positive 6x, which does indeed give us a positive 5x. So these are the factors that we want. Okay, any questions on this so far before we move on to the next part? Now we said any two things that multiply, or two or more things multiply together that equal 0, one of them must be 0, yes? So I know for like x plus 6, we can plug in a value of x to make that 0, yes? Because we can set x to be a certain value to make that 0. The same with x minus 1, yes? Can I change that 4 in any way, shape, or form? Am I able to plug anything in to change 4? Well, no, there's not an x with it, right? So the 4 here is just a scalar. We're not concerned about this 4 out front because there's no variable with it. If it had been 4x, then we could set it equal to 0 and solve. But we can't do anything with just the 4. So here we're just going to have x plus 6 is equal to 0 and x minus 1 is equal to 0. The 4 is just a scalar. It's making everything except for these points equal to 0. Or really not equal to 0. It's changing all of the other values of x outside of the 2 spots where it does equal 0. Well, first thing we can do here is subtract 6, telling us x is equal to negative 6. And for the other one, we can add 1 to both sides, telling us x is equal to 1. And that's it. Any other questions on this here? Are you ready for the next one? Three n squared minus 75. So it is equal to 0, so that's good. Is there a greatest common factor between these two terms? Well, 3 will go into both of them, yes? Because if we factor a 3 out of 3n squared, we're left with n squared. And 3 out of 75 is indeed 25. Now for this one here, do we have a middle term? No. But n squared is still the first term, and 25 is still technically the third term. Just the middle term that would have n is 0. We just don't have one. So that tells us, well, since the 25, our third term, is negative, our signs are opposite. One is going to be positive, and one is going to be negative. Now the factors of the first term, n squared, is going to be n and n. Factors of 25 are 1 and 25 or 5 and 5. Which one do we want to try first? 5 and 5. And if we try this here, n times negative 5 and 5 times n. Well, n times negative 5 is negative 5n plus 5n. And what is negative 5n plus 5n? So do we have a middle term? No, so that means the middle term is 0. So that is the correct set of factors. And technically, the n squared minus 25 is something we call a difference of perfect squares. And we'll go into those more tomorrow. But what it's telling us is that these are the correct factors. And if we're solving to see where n plus 5 and n minus 5 equal 0. So for the first one, n plus 5, well, we can subtract 5 from both sides, telling us n is equal to negative 5. And for the other one, we can add 5 to both sides, telling us n is equal to 5. And that is it with that there. Any questions on any of this here? Any question on anything we've done so far? Okay. I feel like y'all are feeling comfortable with those there. Yes? So let's look at number 8, this one here. Number 8 is a little bit different. What's different about this one here? It equals negative 9. It doesn't equal. So the first thing we need to do is get this thing equal to. So how can I get it equal to 0? we can add 9p to both sides. And that brings up a good point. So 3p squared plus 9p minus 120 is equal to 0, yes? Now when we're solving, we're just wanting to find out what value of p equals 0, yes?
I have a question.
Yes.
How come you then just add the 9?
Because the 3p, the p is being what? Squared. So they're not like terms. Now, Logan, what you said earlier actually does work. Because what we could do is there's a common factor of 3, yes? We could, let's see, here's the other side then, divide every single term by 3 instead of factoring it out. Because it'll do the exact same thing. Because on the last problem, we factored out a 4, yes? Did we end up doing anything with that 4? No. It's what we call a scalar. So everywhere besides where this is 0, it's going to change how it looks, but the values that make this 0 won't change. It won't affect them. Because what we get is 3 divided by 3 is 1, so we're left with plus is equal to 0. If we had factored it out, and I'll write this over to the side, we would have had, not 4, we would have had, well, 3 times p squared plus 3p minus 40 is equal to 0. Yes? And what did we say with the zero product property? Any two things multiplied together equals 0. One of them must be. Can we do anything with that 3? So we're really saying that this here has to equal the only time this doesn't work is if you're dividing by a variable. If there was a constant value of p in all 3, we can't divide it out. Because if we divide that variable out, we've taken one of the solutions away from the answer. We've removed a solution. We can divide by a constant term and pull it out because it's just a number. But we don't want to divide by a variable. All right. 2 sets of parentheses with 3 spaces. If the third term is positive, the signs are the same and they match the sign of the middle term. If the third term is negative, the signs are opposite. So for here, our signs would be positive and minus, plus and minus, because our third term is negative. Now we need the factors of the first and third term. Well, the factors of p squared are, and now the factors of 40 are 1 and 40, 2 and 20, 4 and 10. Does 3 work? No. So 6 won't work either, but 5 and 8. And when I look at the factors, one way I write them down is I start with 1, so 1 and 40. Then I check 2, 2 and 20. 3 doesn't work. 4 and 10 does. 5 and 8. 6 is going to be with 6 point some number, yes? And when the two sides meet, essentially what we're multiplying on both sides meet, we're done. Because the only number after 6 is 7. 7 doesn't work. Next number after 7 is 8 and 5. We already have it. Because once those two sides meet, we've found all the factors. Now looking at these here, which set of factors do we want to try?
5 and 8.
Is it likely 1 and 40 are going to work? No, because there's no way that we're going to change the 1 and increase it because the numbers in front of p are both 1 and 1, yes? So the likelihood that, well, these first two are going to work is very slim. So we can look at 5 and 8. Which one do we want to be positive? And we can check it here. So p times negative 8 is negative 8p. 5 times p is plus 5p. Negative 8 plus 5 is negative 3p. Is that what we wanted? So we can flip the signs. Make one positive, which will tell us that 8p minus 5p is positive 3p. Now we can solve this here. 5 minus p is 0, and p plus 8 is 0. So here we can add 5 to both sides, telling us p is equal to 5. And for the other one, we can subtract 8 from both sides, telling us p is equal to negative 8. If you have your...
I should be alright. Here you go, sir.
Thank you.
Use it well.
Any questions on any of these here? Do we feel pretty comfortable with working these? There's one last one I want to look at, and it's this one here. This one here. Now again, we need this equal to what? 0, yes? So if we want to keep n squared positive, we can subtract the 14 and subtract the 21. We can move everything over there. Or we can move the 7n squared over. We can subtract it, which is just going to tell us that 0 is equal to negative 7n squared plus 14n plus 21. Now looking at this here, is there a greatest common factor between these three terms? 7, yes? But I'm also going to take the negative with it. Because again, I like having that first term, the number that's squared, being positive. So we can factor it out, or we could have divided it out. Now for negative 7n squared, if we factor out the negative 7, we're left with n squared. Now factoring out the negative is really just going to change the signs from negative to positive or positive to negative. So since we have plus 14 in the middle, since it was positive, it's now negative. If we factor a 7 out of 14, 14 divided by 7 is 2n. And the last one, the third term, since it's positive 21, it's going to go from positive 2 and negative 3. Because 21 divided by 7 is 3. So it's possible to pull out a negative and a number at the same time. Now we can have our two sets of parentheses with 3 spaces. If the third term is positive, the signs are the same and they match the sign of the middle term. If the third term is negative, our signs are opposite. Well, here the 3 is negative, so we have plus and minus. What are the factors of n squared? N and n. Our factors of 3 are 1 and 3. Where do we want to put the 3? Negative or positive? Negative. Well, our middle term is what? Negative, yes. So most likely the bigger number, how we multiply them out, should be negative. But we can check it to make sure we got the correct setup. N times negative 3 is 1 times n is, which would give us a negative 2n. So this is the correct setup of how we want these here. So now whenever we have 2 or more things multiplied together equals 0, one of them must be 0. So either n plus 1 is 0, or n minus 3 is 0. And we can solve. So here we would subtract 1 from both sides, telling us n is equal to negative 1. And here we're going to add 3 to both sides, telling us n is equal to 3. So either one of these would be the correct answer. Any questions on this here? So that brings us to your assignment, which is going to be a worksheet. So your assignment's a worksheet.